to my second video with Arduino. Today we're going to look more in depth to the ultrasonic sensor, and it allows it to detect motion. And so we're going to make some cool projects with Arduino using LED lights and experimenting with some other gadgets. So let's hop right in. Alright, so let's hop straight in. So you can see that my Arduino is already on because the lights are lighting up. And my sensor is already in. Notice the position of it. Notice those 4 pins that's connecting it to the breadboard. So now what we're going to do, let's take our first wire. Let me zoom in for you. We're going to take our first wire and connect it in alignment with the first pin. Now we're going to go to the Arduino, and you see this side, we're going to go to GND once again. Good look at that. Then we're going to take our second wire and put it to the 4th pin. So let's get a good look at that. So now we're going to take our Arduino board again, and notice this time we're going to put it to the one below the pin. We already put it, the red one is in, put it to 5V. Just a good look at that. Okay, now we're going to take our third wire. Just get a good look at how everything is set up. We're going to take second wire, put it into the second slot. Okay. Now we're going to plug that in to 13. Take a quick look at that. Then we're going to take our last wire, plug it into the last opening, and plug that into 12. So just take a quick look at everything. Alright, so now let's hop into the code. Alright, so now let's look into the code of the Arduino, and I'm going to post this in the pinned comment so that you can copy this down and put it into your compiler if you choose. So notice here, 13 and 12, those were the pins that we connected the wires to on the Arduino, those pin 13 and pin 12, and these are the variables, echo and trig. Those are of type integer, and they're constant, meaning that they will not be changed. And the duration and distance are 2 initialized variables that we're going to use in the calculations. And remember, we went over initialization statements, so this should be all relatively familiar and pretty similar. So this is the setup. We want pin mode trig, so we want the trig to receive the output. So we want pin 12 to receive output, and we want echo the wire at 13 to receive input, and serial begins ensures serial communication for the Arduino board. So now we're going to go into the loop, the digital write, trig high, that means trig is going to be accepting output. We're going to delay 1000, so we're going to delay 1 second. Remember, we went over that in the last video. We're going to also have trig not accept any more output. And then we want the duration to be the pulse in echo high. So we want echo to receive input at pin 13. And we're going to set that to duration. And then distance equals duration divided by 2 divided by 28.5. So these are the calculations to find the distance and accurately find an acceptable value to output. And so we're just going to print out distance. And so once we connect that to the Arduino board, feel free to copy this down or paste it from the pinned comment. Upload it, and should work no problem. And another tip I have is going to tools going down to serial monitor, and here we're going to see the distances. So try putting your hand in front of it. See, now I put my hand in front of it. It's 6 now. Moving it back, 13, 19, 21. And this is very, very helpful when you want to implement maybe like LEDs or maybe like a buzzer. So we're going to definitely get into that later on in the video. But just copy this down for now and look at these values and just experiment with it. All right, so this is what my Arduino looks like after implementing an LED. Here's how it looks. And so essentially what happens is if it detects a certain distance, like if it's greater or less than 20, the light will shine. So let's get into the code, and then maybe you can try implementing it so that if it's less than 20, the green light shines. If it's greater than 20, the blue light shines. If it's greater than 50, then the red light will shine, etc., etc. So let's get into that right now. Right, so this is the code for the Arduino implementing the first LED, the green LED that I showed on screen previously. And you're going to see relatively the same code with the echo and trig, the serial begin, and then these. But these are some things that I added. So int LED1 equals 2. And so that's just saying that it's going to be receiving input at 2 or output at 2 at pin 2, which is connected to the LED. And if you need a refresher on that or what this initialization statement is, I encourage you to watch video 1 where we were trying to light up an LED, because we're kind of combining both skills in this video. So what's happening is we're getting input and output, or it's connected on the pins at 13, 12, and 2. What's going to be happening is the LED is going, or the pin 2 is going to be receiving output on the Arduino. And then I want you to notice here the certain times that I make the LED light up or don't light up. So we're going to start it off as off. And then you see the distance here, these calculations. We want to check if the distance is less than 20, we want the Arduino to light up. You can play around with this value if you want, make it 18, 10, whatever you want. But I want you to notice something as well. This is an if statement or a conditional. And essentially what happens is if this thing evaluates the true, this is the condition. So if this distance is less than 20, it's pretty self-explanatory. If distance is less than 20, if this evaluates the true, then we'll go into this code. And I want to do something right now. I want you to notice LED1 low. So let's delete this and upload it to our Arduino. I want to take out tools, go to serial monitor, and this is what's going to have our values. So we're going to see 42, 42, 42. So that's the distance. What's going to happen is if I put my hand in front of it, it's going to say 8. Okay, this is 8 now. And then let me show you what happens when I take my hand away. If you did it yourself on your part, what's going on? The LED is not turning off. And that's what makes digital write LED1 low very important, because it returns it to its initial state. We want it to turn on only when distance is less than 20, and if it's not less than 20, we want it to turn off. So what this compiler is saying is, okay, it goes through the loop. This is with this statement in. Okay, trig high, delay 1000, which is wait 1 second. Digital write LED low. So what it's saying is we want to turn the LED off now. So turn it off, go through everything, and then go to this condition. If distance is less than 20, turn the LED on. Okay, well, it's on. Go back to the start of the loop, turn this off, so we return it to its natural state, and then we go through, okay, is distance less than 20? Let's say it is, turn it back on. Okay, so it's going in a loop where it starts the LED as off, then it goes on only if this condition is fulfilled. So now let's take this line off, pi 1000. So it's going to go, okay, let's go through this whole thing. Let's say the distance is less than 20. Okay, turn the LED on, print the distance, go back to the start. Okay, okay, okay. Distance is less than 20. Keep it on. Go, okay. Okay, let's say distance is greater than 20. Okay, then just skip this part, and the LED is going to still be on. So it will never turn off unless we have that statement there to say, turn it off at the start, and then if it's less than 20, then we can turn it back on. And so when you upload this to the compiler, this should work a lot better. See my hand in front of it, 4, 2. See, now the LED turns off, turns back on. And you see how it's always turning off when it's less than 20, when it's greater than 20, and then on only when it is less than 20. That's very important that you go through this code, kind of go through it in your head. Alright, so here are my connections. What I urge you to do now is to pause the video and try implementing multiple LED lights. And so I want you to flash the first light when the distance is less than 10, the second light when the distance is greater than 10 but less than 20, the third light when the distance is greater than 20 but less than 30, and the last light when all conditions else do not apply. And so here is what my setup looks like. Here, let me zoom out for you. If I put my hand here. So we're gonna go into the code. You can copy the circuitry if you don't want to do it yourself. And those are the connections. All right, so let's get into the code. Alright, so this is my code. Once I added the next LED, so pin 3, 4, and 5, you can take a look at it once I display the video on screen. And so these are relatively the same code. These are kind of like replicates or pretty similar to LED 1. But something else that I really want you to notice are these if, else statements. And so what I want to do is let's upload this. You can copy the code and try it out for yourself, but I'm going to demonstrate with an example. So let's pull up the serial monitor. Okay, so let's take a value. Let's say 24, okay? 24 is our value. And so how the compiler thinks of this is distance less than 10? So is 24 less than 10? Well, that's not less than 10. So we're going to go to this one. Is distance greater than or equal to 10? So that is true, it's greater than. And is distance less than or equal to 20? No, 24 is not greater than 20 or equal to 20. So we're going to say this is false and this is true. And what the and symbol does is saying both of these have to be true in order for the whole thing to be true. So this is true, this is false. So true and false, that means it's false. If they're both not true, then it will be false. So now we're going to go to the next line. So that's how these if, else, if statements work. If this is true, then it executes this. But if it's not true, go to the next else, if statement. So since this is false, we're going to go down here now. So is distance greater than 20? Is 24 greater than 20? Yes, 24 is greater than 20. So we're going to say this is true. Is distance or 24, is 24 less than 30? Yes, 24 is less than 30. So this is true and this is true. And so since the and thing, the two and ampersands say this is true and this is true, so then true and true must be true. So this means the digital write LED 3 is high. So this means that the green light will shine. And so now let's upload this again, go to tools, serial monitor. Let's take a different value. So let's say something like 43 or 78. Let's take 78, okay? So we're going to go through this again. 78 less than 10. No, 78 is greater than 10. 78 greater than 10. Yes, it is. Is it less than 20? No, it's not. So this is false. Is it greater than 20? Yes. Is it less than 30? No. So these are all false. Then, since these are all false, then we go to the final statement. This statement says that if the rest are all false, come to me as kind of like a last resort. So digital write LED 4 high. So the red light will shine if all of the rest are false. And so what's going to happen is the red light is going to shine. And that's how this code, the compiler thinks, is it goes through kind of like a series of processing and conditionals. All right, so this is how the Arduino board, or my Arduino board, looks. So I have blue, yellow, green, and red. Maybe you can try something with like the yellow, green, red lights if you want to try something with that, like traffic lights. But essentially, I'm gonna show what my serial monitor looks like. So right now it's at 41. It's at 41 as the distance. So 41 is greater than 30, so that's why the red light is shining. Let me put my hand closer. So that's blue, so that's going to be less than 10. You see that on the serial monitor. Move it back. Yellow, green. So I'm moving my hand back, but it's off screen, and then leave it off, and that's red. So you're going to see on the serial monitor how the compiler thinks and kind of like its correlation to each of the LED lights. It's really cool. You can experiment, maybe add different things. So I really hope you enjoyed the video. This is going to be it. Here's just what my breadboard looks like. You can copy this down. If there's any clarification you need, you can always leave a comment, leave a like. And also subscribe and turn on notifications, because for more exciting projects, for this, we're going to be implementing, for the next video, we're going to be implementing a buzzer and maybe do an alarm clock in the future, so that, let's say if you're like for a specific time, the buzzer will alarm, and then you can like maybe use this motion sensor to turn it off. And so those are some really cool projects in the future, maybe using a remote or maybe using servo motors. So really stay tuned for new projects. You can leave a comment, any questions you have, and the code is going to be in the description. So that's going to be it for this video, and I really hope you enjoyed.